Okay, so here's the next lesson in geometry. It's called proving segment relationships. Okay, so more proofs today. But we're just going to be doing proofs with segments. Tomorrow or the next lesson will be about proofs with angles. Okay, so I just want to recall a previous postulate. We used it in the first unit, and we also used it in the last lesson with paragraph proofs. It's called the segment addition postulate. It says if point B is between A and C, you can say that segment AB plus segment BC equals segment AC. So here we go. So if B is between A and C, the two small segments added together equals the big segment. So we're going to use that in the proofs today, or at least in one proof, maybe more than one. So we talked about the reflexive, symmetric, and transitive properties of equality. And now we're going to do properties of congruence. Now this also came up in the previous lesson, so this is a review as well. But whenever you have a segment, like segment AB being congruent to itself, or an angle being congruent to itself, that's called the reflexive property of congruence. Okay? Not equality. It's of congruence now. And if we have like one segment being congruent to another, like if I say segment AB is congruent to CD, then you can say that segment CD is congruent to AB. That would be called the symmetric property of congruence. And again, even though this lesson is just focused on segments, the next lesson will be on angles, so it also applies to angles. If angle X is congruent to angle Y, then angle Y is congruent to angle X. Okay? So symmetric property of congruence. Not equality, congruence. Look at the symbol, congruence. And the last one, transitive property of congruence. Okay? Again, not equality, but dealing with congruence. I haven't formally given you these, so that's why I'm having you write them now. If segment AB is congruent to segment CD, and segment CD is congruent to EF, then AB is congruent to EF. Same thing for angles. If angle X is congruent to angle Y and angle Y is congruent to angle Z, then angle X is congruent to angle Z. Okay? Has to be in that order, though. Has to be in that order. Okay, so let's try the proofs. Okay? Example 1. So now we're doing 2-column proofs. No more paragraph proofs. At least not today. Okay? So we're given that PQ equals RS. That's my first statement. Reason 1 is given. Okay. You have to prove that PR equals QS. Okay. So how about if I do this? What if I say PQ plus QR equals QR plus RS? Can I do that? Because I'm just adding the same thing to each side. I'm adding QR to each side. So that's the addition property of equality. Okay? Now, how about if I do this? Can I say that PQ plus QR equals PR? And can I say that QR plus RS equals QS? These are two separate statements. PQ plus QR equals PR. And can I say QR plus RS equals QS? Yes, I can. That is the segment addition postulate. And now if you look at step 2, I have PQ plus QR equals QR plus RS. I'm going to replace PQ plus QR with PR, okay? And I'm going to replace QR with plus RS with QS, okay? So I took step 2 and I replaced each side with what it's equal to. So I'm replacing PQ plus QR with PR. okay? I'm replacing QR plus RS with QS. So that's the substitution property. So that's what I had to prove, PR equals QS, and we proved it. Okay. Number 2. Now this is going to look a little different than what you've seen in the past, but not too much different. Okay. It says complete the proof, and we're given 3 pieces of information. Okay. But not all of them are put in the first statement. Okay. And the reason is because it flows better, this proof, if you take this piece of given information and put it down here. And you'll see when we do the problem. Okay. Okay, so here's what we're going to do. If I take this piece of given information and this piece of given information and write it right here, it leads right to the second statement. Look, JK is congruent to KL, and KL is congruent to HJ. So it means that JK, segment JK, is congruent to segment HJ. That is from the transitive property of congruence. So I'll put transitive POC for short. Okay, and now you'll see why the other piece of given information was put in step 3, because now look how it flows. Okay, it flows JK is congruent to HJ, and HJ is congruent to GH. So JK is congruent to GH. So again, that was the transitive property of congruence. Okay, JK is congruent to HJ, and HJ is congruent to GH, so JK is congruent to GH. Transitive property of congruence. And look what we had to prove. We had to prove that GH equals JK. I can get there now, because if you look at step 4, I can get to step 5 now. I can say GH is congruent to JK because of the symmetric property of congruence. Okay. So there's more than one way to do some of these proofs. There's more than one way to do the proof we just did, but that looks pretty good the way we did it. Okay. On to example 3. Complete this proof. E is the midpoint of AC, and EC is congruent to DE. I'm going to label that. I'll do label that. EC is congruent to DE. Okay. So again, this one split up the givens. Okay, that's fine. It will make the proof flow better if we do that. So if you look, statement 1, E is the midpoint of AC. That means it's cut in half. So this half is congruent to that half. So I'll label that. That has 1 tick mark, so I'll put 1 tick mark on here. So I have AE is congruent to EC because E is the midpoint. AE is congruent to segment EC, and that reason is from the previous lesson. That is called the midpoint theorem. So now, again, the reason why the givens were split up is you can see the flow. AE is congruent to EC, and EC is congruent to DE. So I can use the transitive property of congruence and say that AE is congruent to DE, which is what we were asked to prove above. So transitive property of congruence. Transitive POC for short. Okay, one more proof. This one's a little bit longer. You can see we have 3 pieces of given information. Zoom out a little bit. There's 3 pieces of given information. They are all split up in the proof, okay? Again, because that'll make it flow better, okay? That's going to make it flow better when we do the proof. Okay? So it says AB is congruent to DE. I'm just going to label that. Okay? B is the midpoint of AC, and E is the midpoint of DF. So let's start with the first given. Okay? Well, that reason is given. If you look down here, AB is congruent to DE. That was also given to us. If you look at step 5, that was also given to us. So the givens are split up. It's going to help the proof flow better. Okay? If B is the midpoint of AC, that means that the first half is congruent to the second half. So if there's 1 tick mark there, I will also put 1 tick mark there. But check this out. Look, I'm going to write this. I'm going to say this. I'm going to say BC is congruent to AB. Okay? So again, that's called the midpoint theorem. You may be wondering why I wrote BC first. Well, because now I can use the transitive property. If you look at the flow between 2 and 3, BC is congruent to AB, and AB is congruent to DE. So BC is congruent to DE. And a lot of times, so again, that's transitive property of congruence. Now, since this is a really long proof, I'm going to write this down. You don't have to do this. I'm just going to say steps 2 and 3. Those are the steps that I use to use the transitive property of congruence. Okay, it's a big, long proof, so sometimes it's helpful to specify that. You don't have to, but I'm going to do it again later in the proof. Okay. Next, it says E is the midpoint of DF. So if E is the midpoint of DF, that means that this half has got to be congruent to the second half. So I'll put 1 tick mark on that because there's 1 tick mark there. Okay. And if E is the midpoint of DF, like we have in step 5, step 6, I'm going to say that DE is congruent to segment EF. And again, that is the midpoint theorem. And now if you look at steps 4 and 6, if segment BC is congruent to segment DE and segment DE is congruent to segment EF, I can say that segment BC is congruent to segment EF, which is what we were asked to prove above. And I'm using the transitive property of congruence. And since there's a lot of steps in this proof, I'm just going to specify this, that I use steps 4 and 6 for that. Just so that it might be easier to someone reading the proof to see what I did. Steps 4 and 6 I use the transitive property with. Okay. So hopefully that lesson wasn't too bad. At least we're not writing paragraphs in this lesson. Okay. So that was lesson 4, I called it in this unit, proving segment relationships. The next lesson will be similar, but it will be called proving angle relationships.